Hello everyone, welcome back to another tutorial. This tutorial I'm going to discuss about array, loops and memory representations of an array. So let's deep dive to the practical session. How to declare an array. There is a rules. It's the same like a variable declaration, but array will take an argument with the length. When you declare an array can hold multiple values, so we have to provide its length. Array create with a specific length. For example, if we want to create an array for integer, we have to provide int and curly braces and variable names like numbers. And we have two scenarios here. Either we can just declare the variable or we can assign inline. I will provide both example here. If I provide inline declarations 1, 2, 3, 4, we don't have to provide its length. During the declarations, it's create its own length. The rules of getting its length is very easy. Just we will print out variable name dot length, and we can print out how many numbers it can hold. By compiling this file, it will provide the result. Let's compile the files by javac main.java. File compiled, java main. It's 4. So how to declare an array without any assignment? So if we want to create an array for holding 4 numbers, but we will not provide any numbers here, so how can we define? We will just provide here new and int and third brackets, and we have to provide the length here 4. The same way of declarations, and it's a declaration of array with holding no values, but still it has its own length. For example, if we compile the code and run it, it's still 4. So how to assign values inside an array when it's declared or update its value? Before inserting or updating, we will declare array inline and we'll try to print out 1, 2, 3, 4. With one variable numbers, we can have 4 different values. How to print all of them? Here the rules is we have to write the variables names and third brackets, and we have to provide the number of positions, which value we want to print here. For 1 here it will be 0, for 2 it will be 1, for 3 it will be 2, for 4 it will be 3. This is our index, which started from 0 and end with exactly before the length of the array variables. So if we want to print 1 here, we will provide 0 representing the 1 here. So if we compile this project, if we run this project, we are getting 1. What about getting 3? So if 1 is 0, 2 is 1, then 3 will be 2. It is 2. And if I compile the project, if I run it, we're getting 3. So as it is expected, is working like that. So if we declare the array without no values, by default all values will fill up with 0. If I print here any values from 0 to 4, everything will fill with 0. For example, which the value of index 0. We didn't provide any values here for this array, but it's still considered as 0. So compiling it, run it, is 0. Even 2 or 3, if I print here, it will be also 0. So by definitions, any integer variables, it's holding a default value as a 0. So now we will try to understand how array is storing inside memory. Memory, as we understand, is far different than actually what is the internal physical structures and logical structures. A physical memory, it look like this. There is look like similar like Excel or spreadsheet. It oriented as a row and column orientations. And how do we define the values here? If we have any values here in this place, how do we find out this value? We have the same rules like Excel. We have a column number, we have a row number. By the column numbers and then row numbers, we can go exactly in the same position, we can get the values. How it's working? Processor send a memory address to memory controller, and memory controller decode it to memory addresses, and it's called to a AND gates. And by providing the logical mathematical rhythms, AND gate can able to find out where the exactly locations this value is exactly located. This is the physical structure of a memory. But logical structure is far more different than physical structures. A logical structures is divided in multiple parts. One part is the code blocks. Another part we have is application blocks, where every application when started is take a place in memory, and code blocks is a specific applications when it's run. In this code blocks, the programming structure and instructions normally loaded. And when we declare any variables, it take a place at stack memory. And here this memory is stored if it's primitive types. But if it's not primitive types, but it's an array or object types, then this stack located another memory types. It's a heap. For single namings, it provides a few number of cells. For here in array, when we declared integer variables, it create a reference at stack that where this variable will located, and stack point out the heap memory. And by the length in heap memory, it's take the places how many cell is needed. And when we assign any values, it's substitute directly at the heap locations. When you talk about 0, then it's take about these places. When you talk about 1, then value take these places. When we talk about 2, then value take these places. When you talk about 3, then value take these places. And the final and the final blocks is not oftenly take any values, but a flag that length is over. Is over means this memory blocks is end here in this stack or in this block. So in cases when you call a specific numbers, for example number and 2, what happened? We know int variables provide 4 bits of memory. So when we declare a variables, it take a places at stack, and we know where is the first location of this memory. So when we know the first location of the memory, so this is memory address, and when you call 2, then what it happened? The stack address plus 4 means is the capacity of these variables. Integers has its capacity 4 bit, and then multiply with the indexes 2. For here in these cases, if my heap number is 100, then when we call number and 2, that will be something like that. It will comes here 104, it will be 108, it will be 112, because every integer take 4 bits of memory, and that will be 116. So when we call numbers 2, that means this is a 1, 0, this is 0, this is 1, and this is 2. So that means 100 plus 4 into 2 means 8, 108, these places. So when we access any locations values in an array, it's much more faster than we are expected. It's not iterating one by one. Rather, it's jumping the exact memory locations, how the array is represented in memory. And we can provide much value as we want. It's a pretty much larger value than we expected. For example, I'm providing here few numbers: 1, 4, 5, 9, 2, 4, and 5. We can change any values in any locations. If we want to change 5s here, or 9s here, or 2 here, for example, if we want to 2 here, we have to know what is the index of this 2. So 1 is 0, 4 is 1, 5 is 2, 9 is 3, and 2 is 4. So we just change number and we provide the index 4, and we provide the updated values. For example, here is 6. So after these lines, the 2 will replace this and substitute with number 6. And when we print the values, it will not be 2, it will be 6. For example, if we print the value of 4, it will be 6. Let's compile the projects. Let's run it. 6. And if we want to print all of the values in arrays, how we can? We can print it by using loops. As we discussed earlier, we have 3 types of loops. We have for loops. What for takes? For takes 3 arguments here. First arguments, we normally can declare variables, a same kind of variables, maybe 1 or 2 or maybe 3, but same kind of variables. So in our case, we will declare 1 variables that will indicate the index of this array. So we'll provide I. I refers index of this array. And second, we will provide the conditions. These loops will continue until it less than the array's length. So number length. It will execute until the index is less than the array's length. And what we want? We want to shift 1 index per loops or per iterations. So we will provide the print command here, and we'll provide the logic here, and we'll run the projects. And when we run, we'll see 1, 4, 5, 9, 6, 4, 5. Why 6 here? It should be 2, but here in this line we updated the 4th index value with 6. So 6 substitute at the position of 2. So only we can use for in this here to print? No, we can also use while here. But for the printing the array, for is the absolute loops to use. But don't worry, you can use while also. So for using while, we have to define or declare variable before the scope of while. And we have to increment or change any logics inside the while blocks. So we will provide I++. Actually, why is I++? Why not I equal to I plus 1? This is another tricks in Java that's provided by compiler. When you write I equal to I plus 1, then every time I value will increment by 1. But when you provide I++, it's much faster. That compiler provides a very low level and abstract layer of executing this block by incrementing 1. So we will use I++ next time. And if we run this project, let's clear the terminal, compile it first, and run it. Yeah, it's printing the same. But here we have a problem if we use do while loops. It's printing. So next questions, can we use do while for printing an array? Yes, we can, but there is a risk. Do while loops will print once even the argument not satisfied or argument is not true. Even the do while loops will execute once. So if we use do here, and if we print, if we provide the while here, while condition will be I less than number length. Here will not any argument. And if we try to compile and print here, it's printing because array is not empty. But if array is empty, for example, array is empty, then if we run this do while, we will get error, because even array is 0, the loop should not execute, but do while has its own natures. Do while will execute once even the condition is not satisfied. So let's compile this project. Let's run it. Exception. Which kind of exception? Array index out of bounds. But we say this loop should execute when I is less than the array's length. Yeah, I is less than the array's length, because numbers also 0 and I also 0. So that's why it's false. I is 0 and number is 0. So it's not less than, it's equal. Then we should not print anything here inside the do, but it's printing. So it's the nature of do while loops. Even the criteria is not satisfied, do while will execute once minimum. Next video we will see how to represent a text inside a char array.